Hello children, welcome to LUCID Study. In this session, we are starting with real numbers first chapter. Okay. So before going to this chapter, you should know about real numbers in your previous class. Okay. So just recall those real numbers, then we will enter into this chapter. Okay. So now what we are going to discuss in this chapter, let us see. Chapter name is number system. So we will see some algorithms. So first one is to understand division algorithm. Okay, division algorithm we have learned when we are very small, so that we are going to revise now. Next, what are terminating decimals, non-terminating decimals, and irrational numbers in 9th class we have studied. Again we are going to study again those. Next, laws of exponents and their applications. Okay, and last, very important, that is logarithm and its applications we are going to discuss in this chapter. Okay, now let us discuss the number system what you have studied till now. Okay, see, first we have the counting numbers started from 1, 2, 3, 4, 5 like this, right? So those are said to be natural numbers. Later they have concluded that 0 was also required for the numbers, so that they invented 0. Who invented 0? Aryabhatta invented 0. So this 0 was mingled with the numbers, and they gave a new name as whole numbers. Okay, whole numbers means the 0 is added to that natural numbers. After that, again some negative numbers requirement was also there. Negative numbers, positive numbers, and 0 all are included into one number system. That number system is called integers. After that, again we have found some new numbers. Those are fractional numbers. Okay, fractional numbers, 2 by 3, 4 by 3, these are all fractional numbers. Those we invented and we mixed into the integers, and we gave a name to that. Those are rational numbers. Okay, so rational numbers means what? The numbers which can be written in the form of p by q are said to be rational numbers. After that, again we found some other numbers. Those are irrational numbers which cannot be expressed in the form of p by q. Later again we mixed these two numbers into one group. We will call them as real numbers. Okay, so real numbers is the biggest set, biggest group that will contain all the numbers. Okay, what are those? Rational numbers, irrational numbers, integers, whole numbers, natural numbers. All these are mingled into one group. That group we are telling as real numbers. Okay, that is what we are going to discuss in this chapter, right? Now let us enter into the chapter again. See here, in our daily life, numbers are very much useful, right? Whenever you wake up, immediately you will see the watch. So what was the time now? Immediately you will fix, so 9 o'clock I have to get ready and I have to go to school, like, right? So numbers play very important role in our real life. Suppose you went outside to purchase something, so you need to count the money to give to them, right? So here also usage of numbers you can see, right? Again, see, let us look one puzzle. Not only for real life, to solve some puzzles also we required some numbers. So let us see one puzzle. See, in a garden, a swarm of bees are settling in each number of same flowers. When they settle on 2 flowers, 1 bee is left out. See the puzzle. So there are a group of bees. So they are settling on flowers. So if 2 bees on each flower is sitting, then 1 bee is left out. Suppose the group, in that group, 3 bees are sitting in each flower. So 2 bees were be left out. See. Next, when they settle on 4 flowers, then 3 bees left. When they settle 5 on each flower, then no bees were left. So at most there are 50 bees in that group. So how many flowers are there in that garden? How many bees are there? So to understand this type of puzzles, we need numbers. Okay, so that much importance the numbers have in our real life. Not only for purchasing, time and all. For solving these type of puzzles also, we require number system. Okay, right. Now first we will discuss about division algorithm. What do you mean by division algorithm? See here, if you read this, you will not understand anything. Just read out and see how to understand. I will show you. Given positive integers a and b, there exists unique pair of integers q and r satisfying a is equal to bq plus r, where 0 less than or equal to r less than b. Means what? If I give you two numbers, okay, so suppose I gave you two numbers 25 and 10. I have given you two numbers 25 and 10. So division algorithm says us that this big number whatever is there, that is 25, can be written as a 10 into some number, that is q, plus some number, that is some r. Okay, and this r value whatever is there, that is less than or equal to b. So what do you mean by this exactly? Exactly meaning that if you divide the big number with the small number, so then you will have some remainder. The remainder will be less than the second number. That is the meaning. Okay, let us do this. So 25 if I divide with 10. So 10 2s are 20. Remainder how much we have? 5. So now I will write 25 as 25 is equal to, see, 10 into some number, that is 2, plus again some number, that is r. See, 25 I will write as 10 into some number plus some number. Okay, this is known as quotient. That is why we will represent with that q. And this is remainder. That is why I represented with r. And the remainder value will be always lesser than this divisor. Am I right? So remainder value must be always less than this divisor, and it can be 0. Remainder can be 0, no? So that is why 0 less than or equal to r less than b. Understood now? This is called division algorithm. So if I give you two numbers, you can write the bigger number as a small number into some number plus some number. That means if you divide those two numbers, you will have some quotient and you will have some remainder, where the remainder value will be is equal to 0 or it must be less than the second number. That is the meaning of your division algorithm. Okay, so but this event was first recorded, means this was first given by whom? The famous scientist Euclid. Last year you have Euclid geometry. So he wrote one very famous book, that is what? Elements. Okay, he wrote that elements into many books. So this concept whatever is there, he mentioned in his book 7. Okay, so he was the first man to introduce this division algorithm. Okay, so that is why we have to learn about Euclid more, right? Now one more I will give you, you will understand more better, right? So I will take two numbers now. See, suppose if I take 35 and 25, I have taken two numbers. Now in this, which one is bigger? 35 is greater than 25. So therefore 35 can be expressed as 25 into some number plus some number. So what are these two? So those are quotient and remainder. Now let us divide this 35 with the 25, right? Yeah, divide 35 with 25, we will have 25 ones are 25, so remainder is 10. Now how I can write this 35 into some number plus some number? See, 25 ones are 25 plus 10. 25 plus 10, that is 35. What is q here? Q is 1 and r is 10. So q and r are, q is equal to 1 and r is equal to 10. See, the remainder will be always lesser than the first number. Okay, so like this, the division algorithm was given by Euclid first, right? That is why Euclid is a very famous scientist. Okay, and I told you that division algorithm was invented by Euclid, right? So the division algorithm was given to his name, that is Euclid's division algorithm. Okay, now see, what is its application? Why we need to learn this? Okay, already we know this, then why to learn again? Because he gave an algorithm, so that technique used for finding the HCF of two numbers. Okay, to find the HCF of two numbers, this Euclid's division algorithm will be used. Okay, so highest common factor, HCF of two given integers we can find, right? So to find the HCF of two numbers, we should follow some steps. Okay, there are certain steps to be followed to find the HCF of two given numbers, right? So see what are the steps to be followed. See here, what is division algorithm? So to obtain HCF of two positive integers, so two positive integers I am taking, so those are C and D, where C is greater than D. Now we will follow the steps to find the HCF of two numbers. Okay, see the first step, apply Euclid's division lemma. Okay, so that division algorithm only, whatever we have discussed there, he told one name as Euclid's division lemma. Okay, so Euclid's division lemma for C and D, so that we can write C is equal to DQ plus R, where this remainder is 0 less than or equal to R less than D. Okay, this is what Euclid's division lemma. So first we will apply for C and D. So now step 2C, if remainder is equal to 0, then D is the HCF of C and D. If remainder is not equal to 0, then again apply division lemma for D and R. Okay, we will take one example, don't worry. So we will solve that. See next step 3, continue this process until you will get the remainder 0. Wherever you get remainder 0, the divisor will be the HCF of the given two numbers. Right? Let us take one example and we will find out how to find Euclid's division algorithm. So let us take two numbers to find HCF by using Euclid's division algorithm. You can create your own two numbers. Okay, I am creating my two numbers. Those are, see, as example I took. So I will take one example as 25 and 35. So I have taken 25 and 35. Two numbers I have taken. Now I have to find HCF. See, 35 is greater than 25. Now what we will do is, which one is C? This is C is greater than D. Okay, C and D, these two are the numbers. Now I will go for step 1. What is step 1? We need to apply Euclid division lemma on the given numbers. What are given numbers here? C and D. We need to apply Euclid division lemma. What is that? That is 35 is equal to 25 into some number plus some number. So how do we get these two numbers? By dividing 35 by 25. So, okay, so divide 35 by 25, you will have 25 ones are 25, remainder will be 10. Okay, now quotient is 1 and the remainder is 10. So I will write here quotient is equal to 1 and the remainder is equal to 10. So Q is equal to 1, R is equal to 10. Now go for step 2. Step 2, see, if remainder is equal to 0, did we get remainder 0 here? No, we got 10 here, right? If R is equal to 0, then okay. Now if R is not equal to 0, apply Euclid division lemma to D and R. Okay, now step 2, what I have to do? I have to apply Euclid division lemma for D and R. What is D here? 25 and R is 10. Okay, so I will apply Euclid division lemma to this D and R. That is 25 is equal to 10 into some number plus some number. What are these two numbers? So divide 25 by 10, then you will get those two numbers. Divide 25 with 10. So 10 twos are 20, remainder is 5. So quotient how much we got? 2, remainder we got as 5. Okay, so quotient we got 2 and remainder we got 5. So I will write here Q is equal to 2, R is equal to 5. Now still we didn't get remainder 0. Now again whatever the number came here, 10 and 5, these two numbers we need to apply Euclid division lemma again. Okay, so let us apply that. Step 3, Euclid division lemma we need to apply between 10 and 5. Okay, so 10 and 5, see, 10 is equal to 5 into some number plus some number. How we will get? Again divide 10 by 5. So you will have, see, 10 divided by 5, 5 twos are 10, remainder is 0. So quotient is 2, remainder is 0. Remainder, whenever we got the 0, then what is the condition here? Continue this process until the remainder is 0. Remainder we got 0 now. then the divisor at this stage will be the required HCF. What is the divisor here? See, what is the divisor? 5. So HCF is equal to 5. So we got HCF is equal to 5. Okay, so these many steps are there to be followed. Still, suppose if you don't get remainder here also 0, next we need to continue. Okay, whatever remainder we have, this remainder as well as the divisor, for these two we need to apply for Euclid division lemma again, right? Okay, so instead of doing this, is there any other alternate method or not? There is an alternate method. Let us see that what is it. Okay, so a given example is find HCF of 35 and 25. So this is the question. So instead of doing those many steps, is there any easy way to do it? So there is an easy way. See here, divide 35. The bigger number is 35. So first step is common. 35 is greater than 25. So I will divide 35 with 25. Divide now. 25 ones are 25. Now remainder how much? 10. Good. Now what you will do? You do this remainder as the divisor, and this divisor you make into dividend. Now again divide. So 10 2s are 20. So remainder how much now? 5. Now again remainder is you make it as a divisor, and the previous divisor whatever is there, that you make into dividend. So 5 2s are 10. So remainder how much here? Whenever 0 comes, you stop doing. So then this 5 is said to be HCF. So HCF is equal to 5. Okay, how this related to our Euclid algorithm? Let us see. So in step 1 what we did? We did like 35 is equal to 25 into 1 plus 10, right? The same thing we did there. See, 25 into 1 plus 10. Now in second stage, second step, what we did? 25 is equal to 10 into 2 plus 5. See, 10 into 2 plus 5, right? Now in step 3, what we did there? So 10 is equal to 5 into 2 plus 0. That's all. We wrote HCF is equal to 5. Right? So this is the another way to do it. Maybe you know this method, I think. So follow this method in exams. Okay. So this you do in rough and you do this in fair.